We're really excited that you're here with us for Symposium, and we're going to get started. So first, some introductions. I'm Linda. I'm a sophomore at Harker, and I'll be a teacher for this session.
Hi, I'm Anika. I'm a freshman at Harker, and I'll also be a teacher.
Hi, I'm Danica. I'm a sophomore at Harker, and I'll also be teaching for today.
Hi, I'm Selena, and I'll be TAing for you.
Hi, I'm Mindy, and I'll also be a TA.
Hi, I'm Tanvi. I'll also be a TA.
Hi, I'm Isabel, and I'll also be a TA.
Alright, so our first question is just a general discussion about artificial intelligence. You can turn to your neighbor and discuss what do you think of when you first hear artificial intelligence.
I don't think about doing AI. I think about that, and I think about doing it going from my house. Probably
Alright, what were like the main things that you all discussed? Please raise your hand. Yeah.
every
We're trying to firstly like the more positive aspect. Yeah, ChatGPT is definitely a big one. Yeah.
Generating diss tracks on my friends.
Good job, Satya. He did one on me.
Yeah, something other than ChatGPT.
Facial recognition software.
Yeah, for sure, like on your phone and Google Maps. Yeah.
Do you know where the facial recognition software is used? All I know is like there's discrimination in it because of like the data that we're putting in.
Yeah, and we'll be talking a little bit about that later on. Alright. So if you were trying to teach a person rules for what a pig would look like, what would your rules be? Yeah, does that be okay? Do we have any other rules? Just any pig, any pig. Yeah. Chubby. Sure,
Pretty large.
Pretty large. Okay, I'll write these down. Pink, chubby, tail. Anything else we want to add? Yeah.
Maybe covered in mud.
Okay. Covered in mud. Anything else? Yeah.
Damn,
I'll
he
say maybe not for now.
doesn't go with all the like.
Yeah. 4 legs.
Oh, two.
Yeah. 2 ears. Okay, we'll leave it at that for now. And now, let's see. Do we think this will be able to recognize every pig? No. So would it work for some of these? For example, this one, I'm not so sure. Because pink and black. For the cars, okay. Yeah. So essentially, this is kind of the issue with just coming up with our own rules. How do we figure out when there's too many or too little? And then how do we figure out what we can encompass and what we can't? Yeah, so how do we decide what the rules are? That's kind of a main idea of machine learning. Basically, instead of defining your own rules and telling it to the machine, you're going to have the computer look at many, many different examples and learn the rules by itself. So for example, in this slide, when it learns a lot of these images and gets told this is not a pig and this is a pig, it starts to learn some of these rules of what a pig is. However, it doesn't just learn that it's pink, it can learn that it can sometimes be black from the examples. Yeah, it takes in some that are labeled and some, it takes in some that are labeled as pig and some that are not. And the machine learning method learns what these look like, and it comes up with some rules. So, what's the difference between memorizing and learning? Yeah.
Like making connections between things that you know.
Yeah, exactly. I think it's pretty clear that memorizing, you don't actually learn what's going on, you just remember things. Mm-hmm.
Like for AI, it's like they can like distinguish a different picture than what it's in.
Exactly. Yeah, so that's why we need testing data. In AI, there's usually training data where it gets given examples, and then testing data where it doesn't have the labels and it needs to predict if they're pigs or not pigs or whatever application. And that's how we know if it's truly learned the patterns or if it's just memorizing what it's previously seen. And this is a major challenge in models across the board, including ones like ChatGPT. And the reason that AI started working more recently is because we've had much more data and powerful computers. Powerful computers to train and data to learn the examples. As you can tell, like the more examples you get, the better the machine learning method can get. All right, so now we're gonna delve into how some of the algorithms for machine learning works. And I think Tommy's gonna talk about k-nearest neighbors.
Yeah, so the first algorithm that we're going to talk about is called k-nearest neighbors. So you're probably wondering, what is k and, I guess, nearest neighbors? Like, what does the title mean? So k can be any number, I guess. So k is just an integer, I guess. And you're trying to find k of the nearest neighbors. So once you have, I guess, a data point, and you have all of these other data points, you're trying to find k, which is a number, nearest neighbors, to try and classify the data point that you currently have. So it kind of uses the proximity of the data points to other data points to then like classify that one. So you're probably still kind of confused, so let's go into a few examples. So as you can see, this is a graph of apples and oranges. So apples, the weight is 130 and the smoothness is 0.5, so they're kind of on that side of the graph. And for oranges, the weight is 150 and the smoothness is also 0.5, but they're kind of located on this side of the graph. Okay, so the value for k is right now 3. So if you had a fruit in this section, we'd be wondering what kind of fruit is it? So since these 3 data points are like the closest in proximity to kind of around this area, you're going to analyze those 3 data points to then classify your new one. So you're checking the 3 nearest neighbors. And what do you see? You see 2 apples and 1 orange. So then, because 2 is greater than 1, you're going to classify this data point, which was your new data, as an apple. But let's try another example. Say you only have 1 neighbor and you were still trying to find like this data point. So k is 1 and you're still trying to find which fruit this is. You're only going to check the 1 nearest neighbor, which is an orange. So then that happens to classify as an orange. So this kind of like, just kind of shows like how the value of k matters. But it also depends on how many data points that you have and you're trying to analyze. Now I'm going to hand it off to Anika to discuss a little bit about neural networks.
So k-nearest neighbors is one way that you can use machine learning, but another one is biological neural networks. As the title suggests, neural networks is modeled after our own brain, where you may know from 8th grade biology that neurons take new information, process it, and transmit electrical and chemical signals. Now, billions of these are in your brain, and they're all connected to each other by axons. So from this image here, if these are the neurons, these kind of like wires here would be the axons, and they communicate and they are able to make us think and basically do everything that we do. So neural networks is trying to get the machine to do a similar thing. this is an oversimplification of a neural network, but this is kind of the model. You can see that these circles are neurons and they're connected to each other by our version of axons. Similarly, these process information and transmit it. So from the input layer, we have different characteristics or inputs that are fed to it. They're usually, in the examples that we're going to do, they're going to be a 0 or 1 binary, where 0 represents a no and 1 is a yes. And these are passed on by the axons to the new layers, which are called these hidden layers. It's not necessarily one, there can be multiple, but these take this information, process it, and do some further handling. Next thing, there are weights. Weights we'll talk about a bit later, but they're basically the value attached to these inputs, which are their importance or how relevant they are. So over here we have the potassium levels, the blood pressure, the age, the cholesterol, and the sex, which is from which we can kind of infer that the problem would be like around something to do with healthcare. And you would assign based on what you're looking for, like if age is more important than sex, or cholesterol or blood pressure is more important. And finally, after doing all of this processing, you get to a final output, which is yes or no, depending on your question. Now, that was a lot of information, so if you have any questions, you can ask them now, but we're going to go through a few examples to just make them a bit clearer. So first, our question here is, should we go surfing or not? So now we're going to try to find some factors that will influence our decision. Again, with 1 being yes and a negative 1 being no. So one factor are the waves good. And in this case, so we're going to get some passed out.
Bye down, guys. Bye down.
So we'll be doing this activity together, but for the paper that's passed out, that's for the next practice. But in this example, if you could all just have your eyes on the board for now, that would be great. So the waves good is assigned a value input of 1. So we're telling the model that the waves are good. Another factor is it crowded? And here it's a negative 1 because it is not crowded. And finally, it is sharp. Next, we're going to try to find the weights of each, which again is the importance of how much we care about it. We care heavily from 5 because the weight is from a scale of 0 to 5, so 5 is being most important. So from this, we care a lot about the weights being good. And next, we assign a value of 4 for it being shark-free because safety is important. And finally, we don't care as much about if it's crowded or not, so that's assigned a value of 2. In this example, the way that we find our output layer or our final result is by multiplying the inputs by the output, but by the weights. In order to combine our input with how important they are. And here we get that 1 times 5 is 5. Negative 1 times 2 is negative 2, and 1 times 4 is 4. Now, if you add these together, that would be 5 minus 2 plus 4, which would get you the final value of 7. Now, this 7 basically this tells the model that yes, we do want to go surfing because if the final is greater than or equal to 0, then it is a yes, and if it's less than that, it's a no.
Yeah, so I just want to emphasize that this is one example of how a neural network works, with the entire classification being, should we go surfing or not, and then the model should predict yes or no. And we give it these values. The waves are good right now, it's not crowded right now, and it's shark-free. And it needs to infer and tell us, should we go surfing or not. And the weights are what the model learns by itself to figure out how important each value is. Yeah, you had a question? Okay. So now we're going to do an example. And basically, we'll have everyone draw this diagram, and then we'll draw this diagram, and then please put in your, oh sorry. So, okay, yeah. Oh wait, so before everyone gets started, started, can we think of like values that are important for this topic? Okay, I need two other ones. How hard is this?
How well did he practice?
Material comprehension.
I'm gonna go get another one. I think Isabel, I think you probably don't need to. I have a lot of time. Actually, just get like 5. Get like 5.
Okay.
Did you pay attention?
So now, depending on these values, rate yourself either 1 or -1 for each of these, and assign how important you think each of these aspects are. For example, you can choose between 1 to 5. Then do the calculation and get your number.
Did I see it? Did I pay attention? I'm gonna put no.
Oh yeah.
And if you have any questions, you can ask any of the TAs.
Yeah, I got it first time, but you're talking, stop being talking. Stop being talking. Stop being talking. You're so talking. You're so talking. Great. It's done Michael, where'd you get all your science from?
He's definitely Oh, it's great.
Would some people like to share a study as a 5?
Yeah, is it easy as a 3? And did I pay attention
Okay, cool. So what were your inputs in this case? Like the 1 or the 0?
So I wrote 1 for the first one. I put 0 for the second one.
Let's say for negative 1.
Yeah,
Okay, cool. So in this case, when we multiply these, that becomes a 5, plus a negative 3, and then plus a 3, which gets us a 5. So we will pass the test, but using the same inputs, how would we change these weights to get a negative value instead? Like how would you do?
Without changing the inputs.
Yeah,
just
Just
changing the
change it.
Make it AI study 1. Make it 1 3 1.
Let's try that out. So
Make
here
it
we
1 3
had
1.
2, 5, and 2. And in this case, it would be a 2 minus 5 plus 2, which would in fact get a negative 1 or did not study. So you can see that the weights do matter a lot. So we're trying to get our model to get the ideal combination of weights to get a predicted outcome.
Yeah, and just to clarify that this is a simpler example from what actually happens in neural networks. The concept is the same, but obviously there's not just 1 or negative 1. You can have many values in between, especially if there's text. For example, each number represents what the text means with respect to other text, and then the weights are learned. Well, usually there's a lot more neurons also in this environment, and that's why it's not as simple as just negative 1, or it's not just the weights, it's the inputs as well. Yeah, so now we're gonna go through an application of these neural networks. The CNN, the convolutional neural network, was developed in order to look at images and classify them. And the way it works is it used multiple layers of what we were just doing. So each of those 3 neurons, we have a lot more layers of it. And for each layer, it looks at different information. The first layer looks at the smallest, most watered down abstractions, say circles, and it recognizes them. And so it recognizes, given a circle, this is a circle. Then it brings this circle to the next layer and say combines it with more of these lines. This layer learns, given this circle with these sticks around it, it's like this part of a bike. And then this is fed into the full image of a bike. And this one is learn to interpret. Given this, plus say like these, it'll make a bike in the end. And this is kind of how convolutional neural networks work. It uses a lot of abstractions in order to learn. Alright, and this is a quick video describing. Actually, I think we'll skip this video for time. Okay, so we're gonna do a quick introducing activity for convolutional neural networks. This is a game that was developed by Google. How many of you have heard of this? Yeah, basically it uses AI to learn what you're drawing. And you can see that as you draw it, it recognizes objects, and as it becomes more complex, it recognizes everything. So I'll demo it.
I see crab. I do see crab too. I see crab too. Spoon, if you don't. It's a spoon, good job. I see the rock in the movie.
Okay, so some of these were just because I was not good at drawing, but the main idea is this is trained on everything other people have drawn, so it'll be trained on mine as well. So as it sees more of these pictures, it knows what humans usually draw when they see pliers, and as a result, it learns how to predict these things. And it takes the big as a pliers. So now deep learning. So deep learning uses convolutional neural networks, and the way it does this, or any neural networks, but for images convolutional, and it goes through many different training iterations. Each time you give data to the model, and it learns really small scale features at the beginning. For example, conceivably, if you get a lot of these images, you'll start to recognize there's a pattern. Then the next layer learns that once you put some of these together, you'll get a pattern of when this is an eye and when it's not. And then the next one, you combine these images into bigger face images. And as a result, it can tell the very small grain details from this layer and then put together, and then finally for the entire face. So it's kind of like how we look at things as well. When we're first looking at things, it might be hard to see what it is in total, but when we look at small details and then slowly put them together, we can kind of learn what's happening. Alright, so now we're going to do an activity with actual coding, and it's for the K-nearest algorithm that we implemented earlier today. So I know not everyone has their computers. How many people have their computers with them? Because do you think we should have them? Okay, so if you have your computer, you can go to this. You might need to use not your Harker. You might need to use a different The Harker account is locked. And once you get to the document, click copy to drive. Click copy to drive, you get a copy of it. And it might not work with Harker accounts, you might need to use a different.
What was your first off?
Why did it take so long to
No, you're not. I use it. He says you use it for Mr. I use it for you know Mr. What were you trying? Stop.
writing mine? I'm just writing mine. You can delete the message if you don't like it. Do you like it? Yeah.
Copy and drop.
Okay, does everyone who has their computer have it open? Is everyone good? Okay. So, how many people have used Google Colab before? You can raise your hand if you use it. Okay, so yeah, basically Google Colab is a way to run code, like Python code, in your drive instead of on like your computer. And we're gonna use this because a lot of resources are provided for AI and machine learning. And this is some code to implement pay nearest neighbors, which was the algorithm we were talking about before. So our objective is, given a lot of data with oranges and apples and their weight and smoothness, we want to predict if something is an apple or an orange based on weight and smoothness without being given what fruit it is. So first, in your Google Colab, run this code by clicking this button. You'll hover and then you'll see the play button. It might ask you if it might ask you something like pop up and then just say yes. It's around. Yeah, and basically this installs the extensions we need for Python. Okay. And now for the second cell, okay, run the second cell. This also installs Python library. Very good, quiet down. Okay, so now we're gonna read the training data. So click and run the cell, and this reads it from a CSV file that we loaded in previously. So the table you get, does everyone see the table?
Yeah.
Yeah. So this just gives some example points of like the fruit label, and then if it's a weight, if like it's weight, and then it's surface. So this is what our data looks like. So now, does anyone know what they think we should do next?
10.
Graph.
Right.
Yeah, so first we count how many, there's 100 of each. 100 apples, which is 0, 100 oranges. And then does anyone know what's going on here?
It splits it into the.
Sorry, I heard a voice.
Oh wait. Oh, never mind. Oh, it splits it into the training and the testing data.
Yeah, exactly. So some of these will be given with label and the values, and some of them will be given, and that's just for training. And then later on, we'll have the test data, which is 20% of the data set, which will test if our model has actually learned or if it's just memorizing the previous data. Yeah, so now we graph it to take a look at what it looks like. So right here, the green is apples and the orange is oranges. The stars are test data and the circles are train data. We can see the distribution is pretty good. And so, can anyone kind of see like a clear pattern that's going on here? Yeah. Does anyone just want to explain it really quickly? In the data. Yeah.
With the apples, it's on like the left side from like 135 to 150. It's above like the surface with 0.6. So the orange is on the right side and it's below 0.6.
Yeah. Alright, so now we're gonna load in K-nearest neighbors classifier. This is the exact classifier that we were going over earlier with the graphs, and this is just implemented in Python code using a Python library. Yeah. And so now we fit into the training data. So this means that it gets all the data points and learns which ones are smoother, which ones are heavier. And so run that. Okay, so now we're gonna predict. So we use the .predict function to predict it on new test data that I haven't seen before. You can run it. What are some of the accuracies you get? Does everyone get 100? Can you get 99? Okay, cool. So does anyone have like any idea why our accuracy is so good, 100%? Any ideas? Yeah, that's part of it. Do you have any other ideas? Yeah. Sorry? Not exactly. Yeah.
It's clearly distinguishable.
The data? Yeah, exactly. Yeah, so does anyone else have anything?
Like the testing points aren't like close to the others. Like for the oranges and apples, like they're very far away from each other and like in the middle of the train test points.
Yeah, exactly. So those two are both factors. You can see that the data is very simple. You can already, like all of the apples are here, all of the oranges are here. So clearly with the k-nearest neighbors, it'll get the nearest neighbors and it'll get it. So the reason we get such good accuracy is because the data inherently shows a pattern that's really easy to analyze. So yeah, we get 100, and then as we can like put in weights or smoothnesses, and have the model predict if it's a fruit, which fruit it is. So let's say we do like 130, 0.5, and we predict it 0, which is apple. And so you can change these numbers and see if it predicts it well. And so maybe an idea is to try testing in the very middle and see what it'll do. Let's say like 150 and 0.6. Yeah, and it still does that. Yeah. So that was a quick activity that you can keep exploring with. And we're gonna go over this example. So for anyone who wants a more complicated task, like a visualization, that one was really clear. But let's say your data is really difficult. Let's say it could be like Zigid. It doesn't just have to be 2 different squares of data. And depending on that, you'll need to add more neurons and make your algorithm more complicated. So we're just gonna recap what we did today. Does anyone want to raise their hand and say something that they learned? Yes. Anyone else? Or anything you enjoyed, anything that was cool? The CNNs. Anyone else? Yeah, so we went over two algorithms, pair nearest neighbors and neural networks. We looked at how we could apply them. We drew neural networks, which are behind many of the models you see today, including the facial recognition and ChatGPT and a lot more. And yeah, we hope this is like an enjoyable experience for y'all and just an introduction to machine learning. And yeah, so thank you everyone, and you can check out more Symposium activities today. I know there's some STEM Buddies activities.